It's Brad's Laboratory.
My daughter's Microsoft Xbox gaming headset is having problems. This headset was pretty expensive, so I'm going to have to go at fixing it instead of just throwing it away. As you can see, this headset has a microphone as well as the left and right earpieces. It uses a 3.5mm connector with 4 connections. This is called a TRRS connector for tip, ring, sleeve. When plugged into an audio source, no audio can be heard unless the connection is wiggled just right, and then one of the earpieces will spring to life. This indicates that the wires have broken loose in the connector and the connector needs to be replaced. A shopping trip on Amazon and a package of new connectors arrive a few days later. Times like this, I really miss Radio Shack. First thing to do is to cut the old connector off the cable. I cut it close to the connector as possible to keep the wire length as long as possible. Next is to strip back the outer insulation on the cable. I accomplished this with a light score with a razor knife, followed by bending the wire in half and taking another light pass with the knife across until it pops open. I do this very carefully to prevent damaging the internal wires. Then with one side cut open, I rip off the insulation, leaving the internal wires exposed. Inside I find 4 colored wires and a copper shield wire. The copper shield wire is wrapped around the white wire. I gather up its strands and twist them together. The colored wires are blue, red, black, and white. Next I use a pair of wire strippers to strip the wires. These wires are really too small for this pair of strippers. But I know an old trick of tilting the strippers, and this allows them to strip the undergauge wires. The wires are very tiny and are wound around some fabric threads. Sometimes these threads are Kevlar, but I really don't think these were. I continue working to strip the wires and discover that my thumbnail works better than the strippers for this task. Soon, all the wires are stripped. Next, I use a soldering iron to tin the wires. These did not want to take the solder at first, but after letting the wires heat for a bit, the solder flowed onto them. This heat also burns off the threads that the wire strands are wrapped around. The way these wires didn't seem to want to take the solder at first makes me wonder if this is the copper-plated aluminum wire I've been hearing about. Now that I have the wires prepared, it is time to do a little investigative work. I'm going to use a couple of tricks to determine which wire goes to which device in the headset. A visual inspection has shown that the white wire had a shield wrapped around it, so a good guess will be that it is the microphone. The other wires are red, blue, and black. Black is most likely ground. I use my ohm meter to check across the wires, black to red, black to blue, and shield to white. The ohm meter shows that black is the speaker ground, with a black to red reading a 32 ohm speaker and a black to blue reading a 32 ohm speaker. White to shield reads about 730 ohms, which is typical for a microphone. Next it is time to figure out which is the left and which is the right speaker wires. To do this I put on the headset and use a AA battery to activate the speaker by touching it across the wires. I have my green gator clip hooked to the black wire and I touch it to the red and blue wires to figure out which is which. The red wire turns out to be the right speaker and the blue is the left speaker. Now that we know what wires are what, we can determine how to connect the wires to the connector using the most common standard called OMTP. That standard works with Apple phones. Now we have to put the connector back shell, strain relief, plastic insulator, and I am adding a couple pieces of heat shrink. This all needs to go onto the cable now in the correct order. Next I solder the wires under the connector pins one by one. It proves difficult, but I try to bend a hook in the wire end and then hook it to the connector eye. The wires are tiny, and on the shield I give up and just lay it into the solder puddle. I use small heat shrink to insulate the pins from each other. These connectors seem to be pretty cheap, and I have noticed that when the connector barrels are twisted, it spins the connections into each other. I can't do heat shrink on the ground pin due to the 2 wires that get connected there, and I also don't do heat shrink on the sleeve or microphone connection. Next I slide down the first piece of heat shrink in my strain relief stack and use a heat gun to shrink it and the small green heat shrink I used on the pin. Next, the larger piece of red heat shrink is slid down and shrunk. Now the metal clamp that is built into the connector is clamped down onto the cable with a pair of pliers. Next, the plastic insulator that came with the connector is slid down onto the connector, covering the connections and preventing them from shorting to the back shell. Then the gold spring strain relief is slid up and it fits tightly onto the red heat shrink like I had planned. Finally the back shell slid on and screwed down. It is a little tight, so I hold the barrel with pliers to tighten it. Unfortunately, this causes the barrel to flatten. I used the pliers off camera to round it back out before I tested it. Plugging it into my headphone jack, I am able to test the headphones, and they work great. However, I need an adapter that splits out the microphone to a separate port on my computer to test the microphone. Before I could build an adapter, my daughter took them and reported that the microphone worked fine. Hi, Brad here. Thanks for stopping by my channel and watching this video. If you don't mind clicking the subscribe button down here, I'd really appreciate it. It helps me out with YouTube and it's free for you. Also be sure to leave comments and questions in the comment area. I'm always happy to answer those questions. Thanks a lot. I'll see you in the next video.